Today we're going to talk about associated ratios and the value of a ratio. So we have some gumballs. Of these gumballs, the red gumballs are 5/3 the number of the white gumballs. 5/3. What does that exactly mean? Well, if we have a fraction, the top number, the numerator, is always telling us how many pieces total there are. In this case, with a fraction of 5/3, we know that there are 5 total pieces. While the bottom number of the fraction, or the denominator, is telling us how many pieces make a whole, which in this case is 3, which is telling us that there are 3 pieces needed to make one whole. So our fraction, 5/3, is actually saying that we have 5 total pieces and that it takes 3 pieces to make one whole. And what are these pieces that we're talking about? Well, remember they're gumballs. We have red and white gumballs, and we're trying to find red gumballs being 5/3 of white gumballs. Let me show you some illustrations. Does this illustration correctly show red being 5/3 of the white? Or is it this illustration that shows 5/3 red of white? Or red gumballs being 5/3 of the number of white gumballs is shown here? Or is it possible that it's shown here? Red gumballs being 5/3 the number of white gumballs. No, it was the second illustration which was correctly showing red gumballs being 5/3 the number of white gumballs. Why? Well, let's look at some that were not correct. This illustration was not correct because, as we see, we have 3 red blocks and 5 white blocks. Now look at our fraction. Remember, the top number is telling us how many we have, and it's talking about red gumballs. We should have 5. Also, the bottom number, 3, is telling us how many whites it takes to make a whole, and our picture shows 5, not 3. And what about this one? Well, again, we only have 3 red blocks, but we need 5 red gumballs. And we only have 2 white blocks, and we're told that we need 3 to make a whole. No, it can only be this illustration because there are correctly 5 red blocks corresponding to the 5 red gumballs and 3 white blocks corresponding to how many it takes to make a whole, which are 3. Let's talk a bit about the length of movies. So we have 2 movies or films, and here is an illustration of how long they are. We see that film A is the length of 5. Whereas film B is the length of 7. If we were asked to find the ratio of the length of film A to the length of film B, what would we say? Well, let's take a look. Film A, how long is it? Film A is a length of 5. And if we're being asked the ratio of the length of film A, we can plug in the length right here. We've seen that the length of film A is 5. Now for film B. Its length is 7. And because we're being asked the ratio of the length of film A to the length of film B, we can simply plug it in. Here we have the ratio of the length of film A to the length of film B, 5:7. So then, the length of film A is what value of the length of film B? Well, remember, the numerator of a fraction is always telling us the total pieces we have. And so how many total pieces do we have for film A? The number of units or pieces for film A is 5. So we plug that in as our numerator. And now for our denominator, telling us the number of pieces that it takes to make a whole, we simply look at film B and find out how many pieces it has, because that's how many make a whole. And we know that film B is a length of 7, and so we can plug it in for our denominator and see that the length of film A is a value of 5/7 of the length of film B. So then, the length of film B is what exact value of the length of film A? Again, the numerator is the total number of pieces, and because we're talking about film B, we simply plug in the length of film B, 7, because that's the total number that we have. For the denominator, we need to find the number of pieces that it takes to make a whole, and because our standard in this sentence is film A, we look to film A and see that it is a length of 5, and that's how many it takes to make a whole, so we plug it in. And finally see that the length of film B is 7/5 the value of the length of film A. Now we have 2 boys, Sammy and Caden, and they're going fishing, and they're taking shrimp as bait. We learn that Sammy has exactly 8 more shrimp than Caden, which means that Caden has exactly 8 less shrimp than Sammy. Poor kid. We're also told that the total number of shrimp that the boys are taking together is 32. And we are asked, how many shrimp did each boy take? Okay, let's visualize all the data we've been given. Here's Sammy and Caden. We're told that Sammy has 8 more shrimp than Caden, so we can give Sammy 8 units. But because we know that Caden has brought at least something, we need to include this unknown piece because we can see that Sammy here has 8 more than Caden. And lastly, we are told that the total, Caden's shrimp and Sammy's altogether, is equal to 32, so we can label that. We know that Sammy has 8 more shrimp, so let's label his 8 more, like so. And now we're looking at these unknowns. Notice that they are the same amount. Why? Because remember, Sammy has 8 more than Caden. So we have our 8 more, that's those purple squares. But whatever's left over is the same amount as Caden. And the way we can find out these mystery amounts is to simply take away the 8 more that Sammy has from the total, 32. And we see that both of these mystery amounts put together would then be 24, because 24 plus those 8 more that Sammy has would be the 32 total, we're told. Now, to find each individual's amount of this mystery, we simply can cut it in half and give each boy an equal share. So what is 24 cut in half? 12. And since Caden has no more than that, we know that Caden's exact amount is 12. Now, to find Sammy's exact amount, we see his 8 more, and we see the mystery amount, which we now know, is 12. And so his mystery 12 plus his 8 more is 20 total shrimp for Sammy. Let's answer some questions, like what is the ratio of the number of shrimp Sammy brought to the number that Caden brought? Well, Sammy brought 20, and Caden, we found out, brought 12, and so our ratio of Sammy bringing shrimp to Caden is 20 to 12. Now, let's express the number of shrimp that Sammy brought as a fraction of the number of shrimp that Caden brought. So, the numerator ought to be the total number that Sammy brought. Let's see, he brought 20. So the denominator ought to be whatever it takes to make a whole. And look at our phrase of the number of shrimp that Caden brought at the end of this sentence. That tells us we need to look to Caden's total to let us know how many it takes to make a whole. 12. And so the fraction or value that Sammy has compared to Caden is 20 twelfths. What's the ratio of the number of shrimp Sammy brought to the total number of shrimp altogether? Sammy again brought 20, and what's the total? 32. So the ratio of Sammy bringing shrimp to the total number is 20 to 32. So then what is that fraction? The fraction of the total shrimp that Sammy brought. Well, again, Sammy brought 20 out of the total of 32. And so the fraction of the total shrimp that Sammy brought is 20 30-seconds. And now let's talk peanut butter. A grocery store is trying to determine if people like regular crunchy peanut butter or extra crunchy peanut butter better. After a survey, it finds out that out of every 9 people that it surveys, 5 people prefer extra crunchy more. And with that, we can answer the question, what is the ratio of the number of people that prefer extra crunchy to the total number surveyed? Well, how many people preferred extra crunchy? 5. And what was the total number surveyed? 9. Oh, 5 to 9. That's our ratio. But then what is the ratio of the number of people that prefer regular crunchy to the total? Well, if we know that 5 out of every 9 like crunchy, then that only leaves 4 people left, right? 5 plus 4 equals 9. And so those 4 people like regular crunchy, 4 out of every 9. What's the ratio of the number of people that prefer regular crunchy to the number that prefer extra crunchy? Well, remember there were 4 regular crunchy people and 5 extra crunchy. So it's 4 to 5. And now let's flip it. What's the ratio of the extra crunchy people to the regular crunchy? That's right. 5 out of the 9 preferred extra crunchy and 4 preferred regular crunchy, so the ratio is 5 to 4. Now, what if I said that the grocery store is ordering 90,000 jars of peanut butter? How many should they order that are extra crunchy, and how many should be ordered that are regular? Well, let's look at it this way. There are 90,000 that they're going to order. And we know that the ratio of extra crunchy to regular crunchy is 5 to 4. So, we know the total number of units, right? 5 extra crunchy, 4 regular crunchy. Put them together, and that's 9 units. We can then take the total number that they want to order and separate them into unit groups like this. Our 90,000 jars, we're going to put them into 9 different unit groups. And then it will make it easy to put 5 of those groups to the extra crunchy and 4 to the regular crunchy. 90,000 divided into 9 units is 10,000. This means that each of those 9 units are worth 10,000 containers of peanut butter each. And remember our ratio, 5 extra crunchy to 4 regular. And because each unit is worth 10,000, we have 5 groups of 10,000 extra crunchy and 4 groups of 10,000 regular crunchy. Or 50,000 extra crunchy to every 40,000 regular crunchy. Written out, we could say that the company should produce 50,000 containers of the extra crunchy peanut butter and 40,000 of the regular. Okay, so what have we learned about associated ratios and the value of a ratio? We've seen today that taking a ratio, we can know what its value is by simply turning it into a fraction. And because we know that fractions are dealing with parts and wholes, we can look at our totals and our parts of our ratio and convert it easily into a fraction. Because of the way that ratios and fractions are created, both dealing with parts and wholes, we can see that it's easy to switch from the ratio to its value written in fraction form.